In this lesson, we're going to be learning about perfect squares and square roots. The learning target is that I can apply my knowledge of the properties and area of squares so that I can compute perfect squares and square roots of numbers, as well as tell the difference between rational and irrational numbers. I will know I've got it when I score an 85% or better on the assignment following this lesson. So to help us to learn about perfect squares and square roots, we're going to start by looking at rectangles, and we're going to start by looking at the areas of those rectangles. Remember, a rectangle is a four-sided figure, has 90-degree corners, and opposite sides are equal. Okay, an area is how many squares we can fit in the surface of that rectangle. How many 1 by 1 unit squares are we going to fit? And so our prompt here says, hey, determine possible dimensions for a rectangle with an area that has 16 squares. So I want you to see if you can come up with some dimensions, some possible length and a possible width for a rectangle that has an area of 16 square units. So pause the video and see if you can come up with maybe 2 different rectangles whose area is 16 unit squares. And then once you have a couple of them figured out, turn the video back on to see where we're going next. Okay, one of the things I would do if I was working on this prompt might be to draw a picture of a rectangle and kind of indicate what I'm looking for and what I know. I know the area is 16 squares. So I know 16 squares will fit inside this surface. And I'm trying to figure out a length for this and a possible width that creates 16 squares inside this figure. And that will help you maybe to see what you're looking for. So we're trying to find a possible length and a possible width. And there's more than one option for this problem. I said to try to come up with 2 options. So some of our options are, get the image in here. Some of the options we have for this would be to have a rectangle that has 2 units wide by 8 units long. There are 8 squares going across this one row, and I have repeated the same 8 squares below it in row 2, and that gives me a total of 16 squares, which was the condition. It's a rectangle, and I have 16 squares. Another option would be to make one row of 4 and repeat it 4 times. And the dimensions for that rectangle, the length and width are the same. And we get 16 squares. And then the other option, another popular option, is to just do a 1 by 16. So we have one row with 16 squares going straight across. So those were some of your options. The other option would be to just flip this shape over so it's running this way instead of horizontally. And you have the same dimensions going this way. Just doing a quick sketch. Not going to look perfect. I'll do one more row, so I get 8. It would be a 2 by 8 running this way. So we can always flip our shapes over, and that would be this one could be a nice tall 16 by 1 this way. Okay, the dimensions don't change. It's just the order, the length, and the width flip-flop. But either way, we end up with an area of 16. So when we're doing these problems right now, what we should be thinking about are what are the factors of 16, because that's what we use to create these. The factors of 16, let me get my scribble tool here, 1 and 16 are factors that created this rectangle, 2 and 8 are factors that created this rectangle, and 4 and 4 are also factors, but since they're the same, I just count that factor 1 time right here. And the reason that's special and why we only count it 1 time is because it's a square. The sides have the same length. And when you square 4 to the 2nd power, you get the number 16. All right, so we're using division here. And when we divide 16 by 2, we get the number 8. When we divide 16 by 4, we get the number 4. And when we divide 16 by 1, we get the number 16. And I could reverse these, of course, reverse these numbers, and I would end up with the same pairs. So we have factor pairs. The factor pairs are our dimensions. The one we're focusing on today are when the factor pairs are exactly the same. When you divide a number and you get by another number and you end up with the quotient matching the divisor. That's our focus today. And that is what perfect squares and square roots are all about. So we're going to be doing specialized division today called square rooting. Okay, we're going to just review some definitions here and introduce some new vocabulary. Square, this should not be a new term to you, but basically a square is a rectangle. But it's a special one. It's special because all the 4 sides are the same, and rectangles don't require that. But sometimes it happens, and we call those squares. So a rectangle where all 4 sides are equal lengths. And an example would be, let's say this rectangle has a length of 2.5 units this way. That means it's 2.5 units all the way around. It's got the 90-degree corner. That's what that symbol means right here. That indicates that that is a 90-degree corner, the right angle symbol. And 2.5, 2.5. And then a non-example, something that's would not be considered a square. Well, there's 2 reasons you would not consider this a square. First, let me put the dimensions in so you can see. One would be that 3 and 4.2 are not the same measure. The other would be that the corners are not 90 degrees. So all 4 have to be 90 degrees. So this is not a square. Okay, it's not a square. Okay, a perfect square is a square, which also means it's a rectangle, right? It's a square where all side lengths are whole numbers. Perfect squares have to have whole number dimensions. So if we're looking at this right here, again, this is 90 degrees. So that's one condition, and the second condition is the side lengths have to be whole numbers. And these are both the same, and they're both a whole number. A non-example, well, we've got the 90 degree, that works, but if I label these side lengths and I make it a decimal, or it could be a mixed number as a fraction, which would be 4 and 4/5. Sorry, that's not true. 4 1/5 would be the mixed number for both sides. Then right here, this would be not. This is not a perfect square. It's a square, but to be a perfect square, the side lengths have to be whole numbers. So it's important to understand that. So you need to make sure you understand when I say perfect square, what I'm talking about. Whole number dimension of a square. If that dimension, length, or width is a decimal, then it is not considered a perfect square. So right here, I'm writing our perfect square numbers from 1 to 256, and then 400 and 625 are the last 2. So I'm skipping around a bit at the end here. But these are our perfect square numbers, and we've written them in that exponential form. And now we're going to write them in that standard form. So we're going to raise each of these to the second power to come up with the standard form. And I have these perfect squares listed in order. And these are ones you're going to need to memorize. You're going to have to know these perfect square numbers by heart. So we're going to start working together, and then you can continue on your own. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and I want you to continue filling those out. Pause the video while you do that, and then turn the video back on and make sure you have these perfect square numbers in standard form in the bottom row correct. So the numbers, the perfect square numbers multiplied out and these are our common ones. There's, of course, infinitely many of them, but these are the common ones that you're going to need to have memorized. 1, 4, 9, 16, 25, 36, 49, 64, 81, and so on, all the way up to 256. So you have to know the ones from 1 squared to 16 squared. And then we also have to know 20 squared and 25 squared by heart. We use these quite a bit, and just having them to memory is helpful. Okay, it's also good for your number sense when you're trying to estimate and figure things out for numbers that are non-perfect squares. So it's super important to have these to memory. Again, the reason these are perfect square numbers is because when you think about a square and it's a 1 by 1, the dimensions are exactly the same. When you think about this square, it's 2 by 2. This is a whole number with whole number side lengths. Okay, this perfect square is a whole number perfect square, and when you find the dimensions of the square it forms, they're also whole number side lengths, which makes these perfect square numbers. All right, now we're going to talk about the square root. The square root is a special type of division that gives you two identical factors. A special type of division that gives you two identical factors. So when we were doing that problem with the 16, an area of 16, I'm just going to write some long division up here to give you a visual of this specialized division that you're going to be learning today. So the division options were factoring 16, and our options for our choices, if the dimension here was 1, then 16 was on the roof for our long division if we were to write this out in this way. And then sometime we could have picked 2 for our dimension for one of them and factored and found 8 as the other factor. And then finally 4, and then the other factor matched. This right here is square rooting. We had any option we wanted, any 2 factors. They didn't have to match to answer the prompt at the beginning of this lesson. But when we talk about square roots, you're asking for these 2 numbers to match. That there's really only one factor. A square root tells you what number times itself will give you that final product. And the answer to this one was 4. If you take 4, you just get one factor, special. Okay, so the symbol we use to indicate we want to know this specialized answer for division is a square root symbol. It looks like a bit like the long division, but it has this little hook on the front. And that's saying, hey, you can't pick any 2 numbers that go into the 16. You have to find the one that goes in and repeats itself. That's what a square root symbol is. Also, just for information, square root is the opposite of squaring. So if I say 4 squared, that's multiplication. You're multiplying. If I say the square root of 4, that's specialized division. That's asking for what number times itself is 4. That's square rooting. They're inverse operations. They opposite one another. So squaring is the opposite of square rooting, multiplying and division. Okay. All right. So let's come over here to this part right here. So let's find the square root. So here's the square root symbol. Let's start with how to read this. So we have this square root symbol, and I'm going to put 36 underneath it. So how you would read this problem is you would say the square root of 36. That's how you read it. Okay, and let's just list up here the factors of 36 right up here. We're going to do rainbow pairs. 1 and 36, 2 and 18, 3 and 12, 4 and 9, and then 5 doesn't go in, 6 does, 6 and 6, 7 doesn't go in, 8 doesn't go in, 9 does, and now I'm going backwards. So I found them all. Those are all the factors of 36. So if this was just asking you for 2 factors of 36, you could pick any of these, right? But this one right here is the specialized division. When we're saying a square root, we're looking for the factor pair that is itself. In other words, We wouldn't write this notation on our homework or anything, but it would be similar to as if you were doing this, saying, hey, what number can I put here and here that's exactly the same that will give me 36? And the answer is 6. Okay. So the question, when you see this prompt with this little square root and a number underneath, you should be asking yourself what number times itself equals 36. Or you could say what number squared, that means times itself, using our new vocabulary with our exponent, what number squared is 36? And you should come up with 6 times 6 matches, 6 squared matches. So the square root of 36 is that one factor 6. And if you think about a square itself, it's going to have 36 squares in it, and the dimensions have to be exactly the same. So that's square rooting, being able to find one factor that goes into that number because it repeats itself. Okay, let's fill this out at the start together, and then you can keep going on your own. This is not going to be complicated because I've put these in order from smallest to largest. For our common perfect square numbers are underneath these square root symbols. It's also called a radical symbol. Okay, so under this square root or radical symbol is 1. That means what number times, I'm just going to put a little note up here again, what number times itself is 1? And the answer is 1. 1 times 1 is 1. And then what number times itself is 4? 2. What number times itself is 9? 3. So you're doing this division to find the one factor that is a square root of the number underneath. So fill it out. It is in order for your common perfect squares that we just did on the previous part of your notes. And then you fill it out while I'm filling it out. I'm not going to pause it because these are in order. But you're going to need to memorize these. The square root of 36 is 6. The square root of 49 is 7. So keep going. Read them to yourself. Be careful here because I jumped. What's the square root of 400? So if you have an area of 400, what number times itself gives you 400? Well, 2 times 2 is 4, but I need 2 zeros after, so it has to be 20 and 20. And what number times itself gives you 625? And the answer is 25. Okay, so you're going to have to work on memorizing the perfect squares and their square roots. Again, it helps with common ones that we use a lot for our problems and for number sense when we're estimating numbers that are not perfect squares. Speaking of estimating non-perfect square numbers, that's what we're going to work on now. We're going to do a model on a number line on how we can use the number line to get an understanding how to estimate non-perfect square numbers. And then eventually, after you get the hang of it, you can hopefully start making those estimates without using a number line, just using your perfect square root memorized knowledge to make those estimates. So it goes a little quicker. And but this will help you get an understanding of how you have to think about it. Okay, the area we're given for this particular square is 45 units. So what you have to remember is this dimension right here is the same as this dimension right here, here, and here. All 4 sides are equivalent. So we only have to find one factor for our side length because they're all the same. We only need to find one. But we are going to use square root because we are going to find 2 factors that are the same. In other words, one factor. So we're going to start by putting numbers on our number line. So what we're going to start with are 45 falls between 2 perfect square numbers. So that's the first thing we need to figure out. I know that 45 falls between 36, which is a perfect square number, and then the next one that follows 36 is 49. So 45 falls between the perfect square number 36 and the perfect square number 49. So if this had an area of 36, it would be, to find the side length, we'd take the square root of 36. Let's pretend it was 36. We'd say, hey, the side length is 6. S would be 6. Let's pretend that it's the area of the square is now 49. And to find the side length, we take the square root of 49, and that is 7. So what we just discovered is the square root of 45, which would be somewhere on this number line between 36 and 49, is it falls in between the numbers 6 and 7. The square root of 45 falls between 6 and 7. So let's put 45 on our number line in relation to the 36 and the 49. 45, I know, falls between 36 and 49, but I also know it's more than halfway. Okay, the halfway mark between 36 and 49 is going to be let's see, 36 and 49 are 15 units apart. 49 take away 36 is 15. So this has to be 8.5 units higher than 36 and 8.5 units smaller than 49. Sorry, going wrong. It should be 7.5. Apologize for that. 15 cut in half is 7.5. So 7.5 bigger than 36 and 7.5 smaller than 49, which would actually land us at 42.5. All right, so we've got that mark, the halfway mark, and I know that 45 falls to the right of 42.5 between 42.5 and 49, and it's actually only 2.5 units from 42.5, and this is 4 units away, so it's closer to the middle than it is to 49. So we just kind of get a visual there. So let's come down here and just estimate the nearest whole number. What is a good estimate for the square root of 45 to the nearest whole number? Well, looking at our grid so far, the square root of 42.5 would be about 6.5, the halfway mark. So looking at this right now, I'm going to say, hey, it falls between the 6 and 7, and it's closer to 7 than it is to 6. You can see right here, it's to the right of the half Z mark. So if we're rounding or estimating to the nearest whole, you'd say it's closer to 7. So a good estimate is 7 units. Okay. Don't put that 7 there, actually. Take that out because we're going to even get closer. Now I'm going to say, let's see if we can get it closest to the nearest half. Okay, is it closest to 36, 42.5, or 40, or 49? Is it closer to 6, 6.5, or 7? Okay, the square root of 45 falls between, looking here, it falls between 6.5 and 7. But it's closer to 6.5. So for the square root of 45 is closer to 6.5 than it is to 7. So the answer here would be 6.5. That would be your estimate to the nearest half. Okay, so first I would just narrow it down to get its estimate to the nearest whole number, and then from there break it down even further and get closer to a better estimate would be 6.5. That's how we do that. We're going to do a few more to practice because that does take some practice and some looking at different dimensions and getting used to the process. Okay, so here we have another square and the area is 70. And 70 is not a perfect square because it falls between two consecutive perfect square numbers. So we want to get an estimate for the side length. This is going to be a decimal answer, and we want to get a best estimate. First estimate we're going to do is to the nearest whole number, and the second estimate will be trying to get a closer estimate to the actual answer by going to the nearest half. So I know 70 falls between two perfect square numbers, and the two perfect square numbers are 64 and 81. And the halfway mark between 64 and 81, well, these are 17 units apart. So I'm going to need to split 17 in half. And when I split 17 in half, I get 8.5. I don't know what I'm thinking. 8.5. So I have to go up 8.5 from here and down 8.5 from there. And that'll give me that exact half mark, which is 72.5. And I'm going to mark 70 on my number line. It would be closer to the center than it would be to 64. And it would be closer to 64 than it is to 81. So we got a sense of where it is. That's 70. Okay. So finding the side length, which is what we're looking for, we need to take those square roots. So we're going to take the square root of 64, which is 8. And the square root of 81, which is 9. Those are my whole number square roots. And the square root of 72.5 is about 8.5. So we'll put the 8.5 mark right there. All right, and then we're looking for the square root of 70, a good estimate for it. Whoops, I'm writing 90, 70. We're looking for that number. What is it closest to? So first, we'll get it closest to the nearest whole number. The square root of 70 falls between 8 and 9. And it's closer to 8 than it is to 9 because it's to the left of the halfway mark. So it's closer to 8 than it is to 9. All right, so that's one decent estimate to the nearest whole. Now we're going to be more specific. We're going to try to get even a better estimate by going to the nearest half. So we're going to do this one. So when looking at my number line, I'm looking right here. The square root of 70 falls between 8 and 8.5. And when you look, 70 is only 2.5 units from here and 6 units from there. And so if you look at the square root of 70, it's going to be closer to 8.5 than it is to 8. So 8.5 is a better estimate for this problem, 8.5. All right, so we'll go to the next example and practice some more. Okay, I'm going to let you try this one out. Again, we have a square, which means the side lengths are the same, and we're trying to get an estimate of what the side lengths would be if our area was 117. So I want you to go ahead and try to fill out this number line on the top with the areas we're going to use to estimate with, and on the bottom the square roots of those areas, and then fill in the blanks here and here, and see if you can get to the nearest half, an estimate closest to the nearest half a unit. All right, go ahead, pause the video. Turn it back on when you're done to see if you were able to get a good estimate to the nearest half. All right, so if you work this one out, you should have come up with that 117 falls between the two perfect square numbers, 100 and 121. And the halfway mark between 100 and 121 is 10.5 units this way and 10.5 units back, because the spread is 21 apart and half of 21 is 10.5. So we just go up 10.5, down 10.5 to find that middle. Take the square root of 100, you get the side length on the low end, square root of 121, estimate on the high end, and then the middle point would be the square root of 110.5 for your middle zone, 10.5. Plot 117 on there, and you can see it's closer to 11 than it is to 10, so that's our whole number estimate. And then you hone in on this side of the number line, and it's closer to the 11 than it is to the 10.5. So the best estimate to the nearest half for this is 11 units. So if you struggled with that, please copy the information down and then think through that again to help yourself become a good estimator of these non-perfect square numbers. All right, so now we're going to apply what we learned today about square roots. So this is some problem solving and measurement we're going to be doing here. So we have an area for a square that is 16 feet squared, and they're asking us to find the side length. And a lot of times for these, if it's a perfect square number that you have memorized, you think of it as, oh, I know what the side length is for this because I know that 4 times 4 and area's length times width, or in this case, area is s squared because it's the same dimension. 4 times 4 is 16. So I know it's 4, okay? That's one way to think about it. A lot of students will think about it as a multiplication problem, but we were given the area. So your new learn today is to think about this, since it's a square and you're given an area, is to think about it this way. Use different notation. And the notation I'm looking for is that square root symbol. Apply what you learned today. If I want to find the side length of a square, then I'm going to say S equals the opposite of squaring, the opposite. To find it, we divide. We know the total, we got to break it down and find the factor. So we want you to be applying what you learned today, not going back to your old school ways and using multiplication on this problem. Learn a new way. So S is the square root of 16. S is what number? Remember, we think about it this way. What number matches itself up here to give you 16? And that's that 4 and 4. We're dividing. So the answer is 4. So ideally, for your assignment tonight, when you're working on these problem solving or whenever you're assigned problems to practice like this that involve square areas of squares, you're using the square root to find those dimensions. Okay, you're going to want to sometimes use multiplication and just guess and check by multiplying a number times itself, but ideally we want you thinking about square roots. Okay, this is one of those scenarios that the last one you could have done thinking about it as multiplying a number times itself instead of square rooting, but I don't think you want to do that on this problem. It says find the side length. Do you know what two numbers multiply off the top of your head to make 7,225? Probably not. So the best way to go about this is think about it as, hey, instead of trying to guess and check the two numbers that I would need to multiply to get my area, let's just jump to a square root. And we're going to want to use our calculators on this. And your calculator has a square root button on it. So if you have this type of calculator, which was on that supply list at the start of the school year, you would be looking for this button right here, not this one, that's for something else. This button right here, which is that blue, or it might be a different color for you, green, whatever the color is, it says second on it. And then you're looking for your x squared button, which I think is right down here. It has a little x with the 2. And so you're going to hit this first. Then you're going to hit this button right here. And your display will pop up with this square root symbol. Something like this in a parenthesis. And then you just type in the number 7225. And then you hit the parenthesis to close it up, which should be down here, right down here next to that addition multiplication. Close it up, and then you hit the equal sign, or enter it might say. And then that should pop up your answer. So get out your calculator and learn how to use it because you'll need them for some of these problems. Because we didn't memorize this one. And we're not going to use guess and check to figure it out. That'll take too long. You're just going to use your knowledge that, hey, if this is an area and I need to find a side length, I need to take the square root. And it's not a memorized fact like 16 was on the previous problem. So you get out that calculator, and when you punch it in, hopefully you've done that. Second square root, 7225, parenthesis, enter, and you should get 85. So each side length is 85. Ooh, that looks terrible. 85 feet, 85 and 85. They're squares, so all of them are 85. 85, and your units are feet because this is, we're finding the dimensions of the square. Okay, the units for area are squared units because we're counting how many squares, 7,225 squares fit in this space, and that means that the dimensions are 85 this way and 85 feet this way. So, all right, that is that problem right there. Okay, this is going to apply what we just talked about above in the last two problems, as well as our perimeter. Perimeter was an elementary school concept that you learned about and were expected to master. Just a quick refresher, perimeter is the distance on the outside of the figure. So they want to know how far it is all the way around the square, on the outside only. Here's the deal, though. They gave us the area. They gave us how many squares fit on the surface altogether. So we have to use this to eventually get to this. We got to apply our knowledge of area and squares, what we just learned, to get a dimension so we can find the perimeter of the square. So we're going to start with this. First of all, in order to find the perimeter, I need to know the side length S. I need to know what S is. And I have the area of 2,304. A common mistake students make is they think that they can divide the area by 4 to get the dimensions around. That is not correct. Remember, if this is the area and it's a square and we want to know the dimension, we basically need to know the answer to this problem. It's division. But dividing by 4 is not going to work. So, we have to figure out what number times itself gives us this number under the house. That's a square root question. So to find the dimension, we don't put a 4 here. No, no, no. We say, hey, what is the square root of 2,304? And that is not one of our memorized facts, so we go back to that calculator and we punch that into the calculator to see what that side length comes out to be. So punch that into your calculator right now and see what you get. You should have gotten 48. Okay, so we know that the side length is 48, and we know this is a square. That means we have 48 on all 4 sides of our square. To find the perimeter, I just need to add those 48 up. But we're not going to use addition because that'd be crazy. It's the same number 4 times. So to find the perimeter, we're going to take our S value that we just found up here, and we're going to multiply it by 4. So P equals, the perimeter equals 4 times 48. So the perimeter equals, doing some math in my head, 32, 69, 192 equals 192, and we're in feet. So our units for perimeter would be feet. So they gave us area, and because it was a square, we could find the side length using the square root, and once we had the side length, we could quadruple it to get the perimeter of the square. So it's applying what you learned in your previous math courses and what you learned today, and putting those two pieces together to come up with the area. To come up with the perimeter. Okay, in this problem, we are also trying to do some problem solving here using what we learned today and what we know about perimeter again. So this one says we got to figure out the area of the square. Square tells you that the side lengths are the same. So S is going to be our side length, and it's the same all the way around this figure. Then it says the perimeter is 184. Because I know the perimeter is 184, I can use that knowledge to break down my figure to figure out the dimension of the side of the square. So if I know the perimeter is 184, I know I can find S. I can find S because I can take 184. I'm calling S the side length over here. Okay, 184, and I can divide it by 4, and that'll get me one side of my square because all 4 sides total 184. So I end up with 46. 46 is the distance of one side of the square, the length of one side. Okay, so now that I have the length of one side, I'm going to place it here and its feet. That's not what they asked me to find though. They asked me to find the area and it's a square. So to find the area, I'm just going to take, so step 1, I had to find the side length. Step 2, I have to find the area. I'm going to take that 46 and I'm going to square it. That means I'm going to multiply it to itself, and I'm going to drop that into my calculator. You have a square button on your calculator. It's that same button that we use to square root. It's right here. It's an x squared. So what you do is you're going to type 46, and then you're going to type the x squared button. And then from there, you should be able to type enter or equals, and you should get your answer. So go ahead and do that on your calculator to see what you come up with for the area of this square. When I punched it into my calculator, I got 1,764. And that's feet squared because it's area. We're counting how many square units. Going to put my comma in because it is the number to the thousands. So we put commas in those. And that is my area for this problem. So we had to do some steps here. We had to do some critical thinking and problem solving. You had to know that a square's area is the number side length squared, side length times itself. So we need the side length. We didn't have it. We had the perimeter, but it's a square. So we knew to divide that by 4 to get the side length. Once we have it, we square it to get the area and we get our answer. So you got to be able to piece all this together and problem solve through. Okay, that concludes the lesson for today. So you can just make sure to keep your notes handy, and good luck on the assignment that follows this lesson.